Welcome to Brain Vision.
In this example, we're going to be dealing with a tank of nitrogen gas that starts off with 0.85 moles of gas and begins to leak gas out of the tank. So there's a corresponding drop in pressure here from 38 atmospheres to 25 atmospheres. And we also know that the volume and the temperature of the tank are held constant during this entire process. And what we want to figure out is how much mass of nitrogen is actually left in the tank. So first thing to notice is that we don't have to solve for mass right away. We could first figure out the number of moles, which is what the ideal gas law will deal with, and then just convert to mass. So let's start from the ideal gas law, PV equals nRT. And we know that V and T are going to be constant. So if I were to able to isolate V and T and other constants to one side, we know that that value would be constant. So for example, I'm going to divide both sides by V, and I'll have P equals nRT over V. And then I'm going to divide both sides by N. So I'll have P over N is equal to R times T over V. Okay. So T is assumed to be constant, V is assumed to be constant, and R is a constant. It's the ideal gas constant. So this entire value here is constant during our entire process. So what that means is that the left-hand side of our equation here is also constant during the entire process. So we can equate P over N at one point in time to any other point in time during our process. So P initial over N initial is going to be equal to P final over N final. So now if we just take this equation and solve for our final number of moles here, we'll have N final equals N initial times P final over P initial. And that's just if I multiply both sides by N final, and then multiply both sides by N initial over P initial. So once we have this, all we have to do is plug in our final and initial pressures here, which are 38 and 25 atms, and our initial amount of moles, which is 0.85 moles. So we'll have 0.85 moles times 38 atm over 25. So those units cancel. And what we're left with is just 1.292 moles. So we're almost there. We figured out what the final number of moles of nitrogen is in the tank, but we just want to convert this to mass now instead of moles. So the relationship between mass and moles of a substance is that the mass is equal to the number of moles times the molar mass. And the molar mass in our case is that of nitrogen gas, so N2. And we'll have to look that value up in our book or the internet. And the value I will be using is 14.01 grams per mole. So if we were to divide both sides of our equation here by big M, we'll isolate little n. Sorry, I'm thinking too hard about this. All we have to do is multiply our moles by the molar mass here, and then we're good to go. And our moles is 0.85. So if we do that, the final mass comes out to be 18.1 grams. So just to summarize, we figured out how much mass of nitrogen was left in our leaking nitrogen tank by knowing the initial and final pressures, and also knowing that the volume and temperature of the tank were kept constant during that time.